This is John. He was born with one leg shorter than the other. Following multiple operations and after suffering lifelong chronic pain, he opted to have his lower leg amputated in 2017. Over the last 2 years, John has been working with researchers at the University of Bath on a new approach to make a custom-fitted liner for his prosthetic leg. This liner fits him perfectly, making the prosthetic more comfortable to use and helping John to get back to enjoying an active life.
Having your leg chopped off is quite a big deal for the body, and as it recovers, it is very, very swollen. There's a lot of edema and general fluid in the lower limb. As it heals, it shrinks on down as part of recovery, but then also as part of change of use. Just everything changes and shrinks very significantly over the first 18 months. When your socket doesn't fit, obviously it leads to various problems. It can rub, it can tear the skin, generally causes quite a lot of discomfort, which stops people using the leg, which is the key thing, and they end up in a wheelchair.
The researchers at CAMRA, the university's Motion Analysis Centre, first use a scanner to create a 3D image of John's limb stump. The scan is used to design a personalised liner from a flexible polymer material similar to that used in wetsuits.
So for this particular bit of work, we're using a material called neoprene foam, and this is a high impact attenuation foam that allows us to conform precisely to the contours of the patient's requirements. So at the University of Bath, we've developed this technique called cryogenic CNC machining, and this is all to do with machining soft, low-density elastomers. Now, typically, if you wanted to create a personalised product, whether it be a residuum liner or a shoe sole using a soft material elastomer, you'd have to use an injection moulding process. Very expensive, very time-consuming, not great. So our process instead freezes a soft material, so in this case neoprene foam, directly using cryogenic machining methods, so liquid nitrogen. We then directly machine the geometry of the liner onto the material. Thereby we do not have any moulds required at all.
The entire process, from scanning to the liner being fitted, only takes about a day. Researchers from the university's Department of Health use sensors in the prosthetic alongside motion capture technology to analyse John's movement when he walks and see how the new liner affects his gait.
We collect some data using different measurement systems. We use a motion capture system, force plates, and pressure sensors inside the socket of John. The pressure sensor can measure how big is the pressure inside the socket, so we can know if the new liner is reducing the pressure on the stump of John, and this is really important for skin damage and skin problems. Ideally, we would like to have a liner for all the amputees, especially in the first phase after the amputation, because this is a very critical phase where the stump is continuously changing, and they need to wear a prosthesis, they need to walk, they need to do all the kind of daily life activities, and if they have a good fitting, then it's fine for them.
It is really good. I mean, if you don't have the liner, you know, you've got to have it fitted, really, because it's part of your body. And I've been doing my normal jobs, cutting the grass, careers out the fence. To me, it's trying to make life bearable, and this to me, it's making it bearable. It is good. I was impressed. My wife was impressed, and my stump was impressed.
Researchers hope this new approach will significantly improve patients' well-being and help them to get back on their feet.